Good afternoon, everybody. My name is Hejlsberg, and I'm here to talk about what's new in TypeScript. TypeScript basically is about solving this problem. It's about making JavaScript scale. I'm sure it hasn't escaped your attention that JavaScript has seen tremendous growth in the last 5 or 10 years, but in particular the last 5. For a variety of reasons. You know, like JavaScript not just runs in the browser, but runs with Node.js on the server and runs in a variety of native modes on devices like React Native or Cordova or what have you on phones and tablets. And really, JavaScript is the only true cross-platform game in town. You know, even Java, that was originally designed to be cross-platform, isn't really cross-platform anymore. So a lot of developers are writing a lot of apps in JavaScript, but JavaScript was never really designed to be a large-scale application development language. It is a dynamic programming language, which means it has no type system. It was perhaps intended for, 100 or 1,000-line programs, and now we're writing like up to million-line programs. And we all know that programs that are that large take teams, they take scaling, they take a bunch of methodologies that we've already sort of are familiar with in more grown-up environments like, say, C# or Java. So when we were looking at this problem about 5 years ago, about what can we do to make JavaScript scale better, we basically thought that, the ideal solution to this problem would be to add to JavaScript those things that are missing for large-scale app development. An alternative strategy could have been, let's create a new language and just treat JavaScript as the IL of the web and just cross-compile, say, Script Sharp or Java or what have you, But you're never going to be best of breed, and you're never going to get everyone happy if you're targeting one ecosystem from another ecosystem. You want to be in the ecosystem. You want to be of the ecosystem. And so with TypeScript, we basically set out to add these things that are missing. At the time, when we started 5 years ago, JavaScript didn't even have modules or classes. And so those were obviously targets. But in particular, JavaScript doesn't have a static type system. And when you think about what it is that powers the rich development experiences that developers today are accustomed to, like things like code navigation, statement completion, safe refactorings, what have you, error checking before you run your program, all of that comes down to having some ability for the IDE to reason about the code you're writing. And that ability comes from having a static type system. So TypeScript effectively is about creating a statically typed superset of JavaScript that then compiles back to plain JavaScript. So in a sense, TypeScript starts with JavaScript, and then we add an optional static type system. But then when we compile, all of the types go away. So you're sort of left in the development phase of your program with an elevated experience where you have a more grown-up language, but your code is just JavaScript, and it runs everywhere that JavaScript runs. Now, I said being for the JavaScript community, but we also knew that it was very important to be of the JavaScript community, and we decided to write TypeScript in itself. And that means that it is effectively written in JavaScript. And that means that our tool set runs anywhere, in any browser, on any host, and on any operating system. In fact, if someone had told me 10 years ago, Anders, in 5 years, you're going to be writing compilers in JavaScript, I go, that's a good one. But here we are. And it's quite amazing how far these JavaScript runtimes have come and how capable they are. The Chakra runtime that we have in Edge, or the V8 runtime that Google has in Chrome or Node.js, it's amazing. It's amazing what they can do. And we are indeed writing compilers, not just compilers. We're writing entire IDEs and development tools in JavaScript, and they work beautifully, as you'll see. And of course, we said from the onset, we want this to be an open source project. We've been hosted on GitHub now for over 3 years. We started out on Codeplex, but soon realized that we got to go where the action is and move to GitHub. That's our daily workflow. The entire team sits in a team room in Redmond, but basically works on GitHub. We take lots of contributions from the community, and it's a fun way to work. It really is. I'm writing more code these days than I ever have before. Now, if I had to sum up, TypeScript really sort of brings 2 key things to the table, key benefits. One is great tools enabled by static types, and the other is the ability to use features from the future today, which basically boils down to a capability called transpilation. Let me try to motivate that a little. In JavaScript, let's say you go back, say, 2 years to May of 2015, this was sort of the state of JavaScript back then. ECMAScript 2015 was just about to be ratified, yet on the server, Node.js has only just made it to ES5, and most browsers didn't even support ES5 yet. And so there's this gap between what you have to target in order to make your app run and what you want to use as a developer. And that's what I call the feature gap. And that gap is actually, it's not a one-time phenomenon. It's a thing that just sort of continues to exist. Here we are now 2 years later. We're about to ratify ES 2017, yet on the server, Node.js has yet to get ECMAScript 2015 modules. They're still doing CommonJS. And we've only just gotten to the point where you can assume ECMAScript 5 in your browser. So this gap continues to be there. And in fact, it's a gap that will probably always be there. It's going to take a while for all these old Android phones to catch up with the latest and greatest. And by the time they do, the latest and greatest will have moved. So in that gap, we can fill this gap by transpiling the latest and greatest version of JavaScript down to older targets, and you'll see me demoing that. So that is those are the 2 key things that TypeScript brings to the table. Now, in this talk, I'm going to do a quick summary of what it looks like to use TypeScript, and then we're going to go into what have we done in the last year and where are we going with the product. But so bear with me, there's a bunch of people here who may have not seen the product in use at all, and so we're just going to set that up a little bit. I'm going to switch to my demo machine here. And we're going to write some code here. So I'm going to fire up Visual Studio Code, which I'm sure, how many of you use Visual Studio Code, just out of curiosity? Wow, see your arms. Yeah, wonderful. Visual Studio Code is our open source IDE. I am proud to say that it is entirely written in TypeScript. So everything you see me do here is written in TypeScript, runs on a JavaScript VM. Visual Studio Code also uses the Electron shell, which basically embeds WebKit and Node and the V8 execution engine and allows you to build desktop apps that way. And that's what we're looking at here. And of course, it runs everywhere on Macs, Linux, etc. OK, I just have a piece of JavaScript here. It's by inspection, you can see it's a function that sorts an array, but who knows what it does, because it has no types. There's nothing really that says what's going on here. We can see there's a parameter called a, but we don't know anything about a, and therefore we don't know anything about any of the things that are in here. They're just all of type any if I hover. We do know, and we can give you statement completion on there being a function called sort by name, but you can pass anything you want to it, then hey, it's JavaScript. You know, it's gonna blow up at some point, but not yet. Now, what if we could actually say more about our intent? Well, so let me first rename this to TypeScript. So I'm just going to rename this file to main.ts, and lo and behold, nothing changes, because TypeScript is a superset of JavaScript. So anything you can do in JavaScript, you can do in TypeScript. But now you can do more things. Specifically, you can add types that describe what you're intending to do here. So I'm going to, for example, insert an interface declaration of a person, which is a thing that has two properties, name and age. And then I'm going to say the array here is actually a person array. And once I do that, you see stuff starts to light up. All of a sudden down here, if we hover, it says, hey, the number 5 is not an array. Yep, that is true, but so let's try and pass an empty array, and now we're good there. And then we get some errors in here. So let's see how did we get that error. So A now is of type person array, and that means that the slice method, we know what it does, and it returns another person array, so that's the type of result. And result then has a sort method because it's an array, and sort gets you a callback function that passes you two values that must be persons, we can infer. And so we can actually push the types from that single annotation. We have now strongly typed everything in this little function and pushed the types everywhere. And so when I'm writing in here and I say return x dot, you'll see I get statement completion on what the properties are. And since name is a string, we know there's a locale compare method, and I can pass to that y dot name. And here you just saw we found the error. I had misspelled local compare or locale compare. It's really I had spelled it local compare, but that was wrong. Now the checker can find that error for me. So now you're going to wonder, well, where did this information come from? You know, how do you know that an array has these methods? So if I say a dot, here are all the methods of array. Where did they come from? Well, we could try to say go to definition on the slice method here. I'll just press F12. And that jumps us into a file called lib.d.ts. This is what we call a declaration file. You could sort of think of it as header files for the web or header files for JavaScript. It's a file that contains all the type information for the entire JavaScript runtime library and the DOM. This is a very big file, actually. If we go to, let's go to the bottom here. 21,500 lines. Now, and these are the 21,500 lines of type declarations that, as a JavaScript developer, you're supposed to know by heart, right? Because where else is it going to come from? So when you're typing your JavaScript, this is just stuff that you either have to go look up or whatever. But now, by writing it down and by having a set of tools that understand it, we can actually serve it up in context and show you all of this, and we can use it to check your code. So the cool thing is that we can provide the type information after the fact. We don't have to write our code in TypeScript to get a type check. We can actually take plain old JavaScript frameworks and then go write declaration files for them, and all of a sudden, poof, you get a better experience. And of course, the community has obviously discovered that, and by now, the open source community has collected in excess of 3,000 declaration files for all of the popular JavaScript frameworks that are out there. And we now automatically package them up and make them NPM packages that are just installable. And we'll see that in later in the talk here. So let me try now to show you some of the transpilation capabilities. So let me, for example, try to use a feature that got introduced in ECMAScript 2015, which is arrow functions. And you'll see that my editor allows me to do it. We understand what it is, but let's try and figure out how that actually gets compiled into JavaScript. So I'll go back here, and then I'm going to start create an init and a configuration file for TypeScript, and then I'm going to start the compiler in watch mode. And now the compiler just sits, and whenever I save, it automatically compiles my file into JavaScript. So now let me try to open in a different window here. We'll put main.js over here. Oops, that's not what I wanted to do. We want main.ts in this window, and we want main.js over there. And here you see the same code that I wrote, but all of the types have been erased. You see that we're back to what we sort of started out with, right? But you also see that the arrow function I wrote got translated into a regular function over here because our compile target is ECMAScript 5, and ECMAScript 5 does not support arrow functions. Now, let me try to add a class declaration also, and let me try and save my file, and then you'll see the watch mode, the compiler in watch mode behind the scenes automatically recompiles the code and turns the class into idiomatic ECMAScript 5 that basically is the code that you would have to write before classes were introduced, and that you may have to write if you want to run on something that isn't yet ECMAScript 2015 compliant. Now, we can actually play with this, and we can bring up our config file, and then we can change the target that we're compiling to ECMAScript 6. And let me just save the config file, and then you'll see that the output immediately jumps, and now it becomes ECMAScript 6, but with the types erased, right? So basically, there's this dial that you can set to whatever level you want from a single source base. You get to use the latest features, but you get to run on whatever target, down-level target you want. OK, so that is a very quick introduction to some of the features of TypeScript. Now, let's try to look at what real-world use of TypeScript looks like. I'm sure some of you heard that a couple of years ago we entered, or more like 2.5 years ago now, we entered into a partnership with the Angular team at Google. They were working on Angular 2, the next version of the Angular framework. And they were talking about a thing called AppScript that was sort of like a superset of TypeScript. And we go, hey, why don't we work together? We can do whatever features it is that you need. Like they needed decorators. And so we go, we can do decorators. So why don't we go away and do that? And we did. And then they took a look at it. They go, wow, this is great. And they decided to write Angular 2 in TypeScript. And that's now been ongoing for quite a while. In fact, they shipped it. And now they've also shipped Angular 4, which was the next version, and 4.1, which introduced strict null checking and whatever. And so there's an awful lot of code now in the wild written in Angular. And let me try and go find some of it here. We'll go to this one site called Angular Expo that is sort of an expo of a bunch of cool apps written in Angular. There's a SoundCloud client that was written in Angular. We can try and run it here. And it's sort of a full-featured player for SoundCloud. I didn't hook up my sound here, but it actually does play the songs, and it's kind of cool. Now, it also is open source. It's hosted on GitHub. Here's the repository for this app. And I've cloned that repo on this machine here. So here it is. And let's try to fire up the IDE here and take a look at this code. In fact, well, let's first try to run it. So I'm just going to npm start in here. This comes with an npm script that automatically sets up a Webpack development server. What you're seeing it do here is, it's on the first start, it compiles and packages everything. Webpack is basically this technology that can take a whole bunch of ECMAScript 2015 modules and package them into a single file that you then reference. So instead of having to download 900 modules, you download one file. And it can also do tree shaking and do all sorts of cool stuff. So we built the app here. And now let me try go to localhost 3000. And here you see a local copy of the same app running. And I didn't really change anything. But now let me try and show you what the workflow is like in an app like this. You can see that in the IDE here, we can navigate code. It's a modern app, that has import statements and uses classes and whatever. We can say go to definition of app module. You see that it uses decorators here to add a whole bunch of metadata. There's an app header component, which is the header band on my app. And you see in here, there's like this SoundCloud Angular 2 title, which is this title that we see up here. So we could try to modify that and just see what happens with the workflow. So let's try and say hello build here instead. And before I press save, let me do a little window rearranging magic here so we can see all of the players in action here. I'm going to put that window there, and I'm going to put these windows over here. And now I'm going to go back in the editor here, and let's see, where was our change? Oops, right here. And now I'm just going to press Control-S, and you'll see what happens here is Webpack picks up on the file change, does an incremental repackaging, and then auto-refreshes the browser. So thank you. So we know by experience that JavaScript developers like to be in this mode of just edit and save and immediately watch the changes. But of course, we have a whole tooling pipeline here that needs to get in the picture. But all of that has been engineered so that Webpack can use our compiler as a transpiler service that can transpile the modules. It can automatically repackage. It can automatically refresh the browser. And you get exactly the same experience that you know from playing JavaScript, but with a much higher level programming language. So that's what it looks like to use Angular. Another very popular framework out there is React from Facebook and the associated React Native. And I got another little example here that I want to bring up. Let me just, my machine went to sleep. Let me log in again. Let me switch to this machine here, which is a MacBook, also running Visual Studio Code. Over here, I want to show you a React Native app that comes from a company called Artsy, which is a company that does a fine art marketplace, and they do all of their development open source, and they built a whole bunch of cool open source React Native components. And I have cloned a repository of theirs for a demo project called Emission, and I'm running it right here live in an iPhone emulator. Let me try to bring that up. And in here, you see that I'm on the sort of the home page of this app here. And in this home page is actually written as a React component. In fact, it's this file, home.tsx. So you're going to, what does this X mean? We know that TS is TypeScript. Well, TSX is the TypeScript version of JSX. And JSX is a dialect of JavaScript. It's JavaScript, but it also allows you to embed JSX markup. So basically, you can have code and markup in the same file, kind of like script text, but with JavaScript on top instead, if you will, and where markup is basically like another form of expression element that you can have. So let's look at what that looks like in here. If we scroll down, there's every JSX component has a render method, and in here you see how it just returns markup. And in this markup, you can sort of switch between markup and JavaScript code very seamlessly. So you see how you can composite a list view, and then inside the list view, you can have some JavaScript code that runs that then in turn puts other markup in there. And you can even define markup components yourself. So for example, here is a search bar component. And we actually understand JSX in TypeScript. And not only do we understand it, but we understand the types of the markup as well. So you can actually navigate on your markup. So I can say, go to definition. I'll press function F12 on my search bar, and it jumps to the class called search bar, which implements that component. And that component, in turn, has a render method that in a compositing fashion uses finer-grained markup, and so it all sort of breaks down that way. Now in here, I could actually go refactor my markup. So let me try to say function F2 and call this one Art Finder instead. And notice that we changed the name of the class here, but if we go back, oops, let me go, what is it? How do we navigate back? Well, we can navigate back to the home page here. You'll see that it changed over here as well. So when you refactor your markup, you actually refactor not just JavaScript, but also the markup, which is pretty darn cool. Let me try to modify my search bar a little bit. You see that it has a, the text here says search for artist and whatever. We'll say hello build here. And let me just save, and actually I should save both files. Let me save this guy, and let me save this guy over here. There we go. Did it not dot reload. Nope. Okay, I think I should have saved both of them at the same time. Anyway, you get the idea here that you can hot reload your app here and see the markup changes reflected in, but that kind of broke for me there. Sorry about that. Anyway, that's sort of a quick example of React Native. Another framework that's become very popular of late is a framework called Vue.js. And I wanted to show you sort of the workflow with TypeScript and Vue as well. So let me try to go there. Vue.js, okay. And in here we have a small start Webpack on this guy as well in watch mode. Keep that in the background, and then let me start index.html, start the app just so you can see what this looks like. It's a little to-do MVC app written using Vue, so I can type in some stuff, hello world, test, and I can check them off, but there's a part of the app that doesn't work. This clear completed here has no effect, so let's go see what's going on with that. So we'll try to go back here and fire up code, and let's look at the code here. So this app starts in main, which is, again, modern app that uses Webpack. It has a to-do app.vue that it imports here. And this is an interesting file here. It's a .vue file. And a .vue file has both markup and code in the same file in a template section for the markup, and then in a script tag for the code. And you could also have CSS in there. It could sort of all be packaged together. Now, the reason this all works in here, in fact, you see that when I hover over it in here, I actually get IntelliSense, and I'll get statement completion and so forth. This works because someone has built an extension, plugged it in, and we plugged it into VS Code here with tooling for Vue. And let me try to show you also, as part of this, some of the work that we did in TypeScript 2.3 is enables us to understand the pattern used by Vue when you're defining new components, which gives you a great authoring experience. You see that in here, a component is written by calling vue.extend, and then you pass in an object literal that has a components property and a props property and a data property and a methods property. And then Vue mungles all of this together and makes an object out of it. And then when it calls methods, then this object inside those methods is actually the combination of taking all of that and making it into data properties and computed properties. So when I'm in here and I say this dot, you'll see that we actually, let me scroll up here so you can see it a little bit better. I say this dot, for example, to-dos. You see statement completion here. This information actually came from this object here, returned by the data method. Likewise, create to-do came from the methods that I had in my methods section of my object literal. So TypeScript 2.3 actually allows you to express that mapping that occurs statically, so we can compute what this is going to be when you're creating a component like this, which is not a simple thing to do, but it gives a great development experience for writing code in using Vue. Let's just try to fix the little bug that the app had, which is that I had commented out this line here, so we can say this dot to-dos equals this dot remaining, and we can just save. This will automatically repackage. I can simply go back and refresh here, type in some stuff, and then try to say clear completed, and now that works. Okay, so those are like, there's a whirlwind, like 3 different frameworks that you can use with TypeScript. And I think my point here is, A, you get that modern JavaScript-like workflow, but you have an elevated experience where you get all the tooling that you're accustomed to from grown-up programming languages, if you will. And B, perhaps more subtly, is that TypeScript really is, in a sense, Switzerland for frameworks. You know, we don't we are not like affinitized with a particular framework. We really strive very, very hard to do a good job of any of the popular frameworks out there. And we're always on the watch because there's a lot going on in this JavaScript community, new frameworks coming online all the time. And so Vue.js, that was TypeScript 2.3. We reached out to Evan Yu, who's written that, and like worked with him to like make the development experience even better than it already was. Okay, let me go back to the slides quickly, and let's talk a little bit about our release cadence and how we go about developing TypeScript. So in the last 8 months, we have released 4 times, 2.0, 2.1, 2.2, 2.3. I've put up sort of like the 2 major features from each release here, but there were a lot of new features that happened. This is some of them, and they didn't even fit on the slide. The team moves really quickly. We're actually now, we have converged on a 2-month cadence, and we co-ship with Visual Studio Code. So whenever they ship, we ship a new version of TypeScript, and we just snap whatever is done at the time. So instead of like trying to determine, oh, we really want to get these features in, we get in whatever we get in, and if we don't get in that train, then it gets into the next one. The way we work as a team is, as I said, we're all on GitHub. We have a lot of tests that we run in our repo. We never accept pull requests unless our 55,000 tests pass. And if it's a new feature, it has to come with new tests as well. And whenever pull requests go in, they go into TypeScript at next, which you can npm install. And we actually have a large portion of the community always running on the nightly build, because the quality of the nightly build is so high that you can get away with, and that way you have all the latest features. But for us, it means that we're effectively perpetually in beta. There is really no such thing as beta, because beta happens every night, you know, whenever we do the nightly build, right? And lots of people pick it up. We immediately hear about issues if there are issues. So in turn, this allows us to move that much faster. So it's sort of this virtuous cycle, you know, that just keeps on going. I wanted to show you some of those new features that have gone into TypeScript over the past 8 months. And I'm going to start by probably showing you what I think is by far the most impactful one. Whoops, let me switch to my demo machine here. So in TypeScript 2.0, we introduced a feature called non-nullable types, which it's actually quite remarkable. If you think about, like, well, let me ask it this way. How many of you have ever had a null pointer exception? Right? Isn't it remarkable that we still have null pointer exceptions? I mean, like after all these years, we still battle with nulls. Tony Hoare, who's now at Microsoft Research, who actually invented null, called it his $1 billion mistake later in life. Because it actually, like, he could document that it at least cost $1 billion in lost work and whatever. And now JavaScript actually not only has null, it also has undefined. So this is the $2 billion mistake in JavaScript. And so for TypeScript 2.0, one of our big pushes was we're gonna make some progress on this problem. Now the way we went about making that progress was originally in TypeScript 1.0. Null and undefined were valid values of any type. So that meant like any string, number, whatever, you could always assign null or undefined. And that, of course, means that it's very hard to track effects of null and undefined if every type allows null and undefined. So really the crux of this work is to say we introduce a new stricter checking mode. And in that mode, null and undefined are not valid values of any types other than 2 new types, one called null, which has the value null, the only value is null, and one called undefined, whose only value is the value undefined. So they're unit types, effectively. And then we use union types to combine them. So if you want a string that can also be null, then you say string or null, or a number that can also be undefined, or a number or undefined. You get the idea. OK. that said, here's a little piece of code. I am going to load up my config file, and then I'm going to turn on strict checking. Save that config file. And now when I go back here, you'll see that some errors appear that weren't there before. And these are all related to nulls and undefined. So let's try to chase them down and see what we can do to fix them. First thing is we notice that we get complaints about the variable count not being assigned before it is used. Now, what's going on here is that the compiler is now performing what we call control flow-based type analysis. And that means the compiler analyzes all possible flows of control in your code, and then at every point where you reference a variable, it determines whether at all of the possible preceding code paths this variable has been assigned. And in fact, it analyzes what type the variable gets as a result of all of the code that preceded you to that point, right? So if there was a check for not equal to null, well, then we know that we can remove that from the type as we go into that reference. So in a sense, as a side effect of the null and undefined work, we get definite assignment checking. And here we see, we've discovered that you didn't assign a count. So now let me naively try to fix that by saying count equals 0 inside the for loop, which obviously is not what I want to do. But that causes this error to go away, but not that one, because here there's still a code path that gets me there without getting rid of the undefined. So really, the fix is more likely to say equal to 0 up here in the definition of the variable. And in fact, I don't even need to have a type on it anymore. I can just say equal to 0, and then we infer that. And now we know that in all code paths, we're good with that. So that was one of the issues. Now, another issue here is this complaint that object is possibly undefined on my text parameter. Now, text is declared here to be an optional parameter. That's what this question mark indicates. And optional parameters can be undefined because that's what you get if the parameter wasn't passed to you. Now, I could fix the bug by saying, oh, no, it shouldn't be undefined, well, or it shouldn't be optional. But now I get an error down here saying, you can't not pass text to me. But let's say I do want it to be optional. Now I have to somehow check whether I got a text passed. Now, one naive way I could do that is I could say if text and surround this whole thing with a truthy check, like that. And that takes care of the problem in here, but now something else happened up here. Function lacks ending return statement, and return does not include undefined. So basically, the type checker has concluded you could fall out the bottom, and that would cause you to return undefined. But you've said that you return a number, and a number can't be undefined, and so you got to do something about that. So I could say here return 0, and then that error would go away. Now, that's one way I could fix this. I could also instead say, do sort of the bailout style. If not text, return, and then do the rest. And now we're good, except, well, not quite. Type undefined is not a, you must return something, so you have to return 0 or something. So see, it's getting pretty hard to cheat this type checker. It's really looking over your shoulder here. Now, of course, probably the real way we want to fix this is to surround it here to say if text, do the for loop, right? OK. There we go. So that leaves one bug in my code. It says here that argument of type string or null array is not assignable to a string array. Well, so we're trying to pass a null, but we said that it was going to be an array of strings. So I guess we either have to get rid of the null, or we have to include it in the type up here, which we could do. And once we do that, then another issue now pops up. This object is possibly null, so now we got to go chase that one down and say if line and line.length, blah, blah, blah. Now we're good. So as you can tell here, this is much, much deeper type checking than you've seen previously, right? And this really does catch an awful lot of bugs in your code. So I would definitely encourage you to use this new strict null checking mode if you're not using it already. Just for kicks, let's look at here just a few more of the effects of nulls and undefineds. Here's some crazy functions. Like here's a function that takes a string or a string array or null or undefined, and then some code. Here we say if s, so we're checking if s is truthy. And in here, as expected, we get it's either a string or a string array. We got rid of null or undefined. But what do you think the type is down here? It's actually string or null or undefined, because the string could have been empty, and an empty string is falsy, and so we actually might have a string down here, and the checker knows this. Now, but when you're writing the code, you probably forgot about that, right? I mean, so these are like the gotchas. The JavaScript is full of gotchas, but the beauty of type checkers is that type checkers don't care about screwy rules. As long as you put them in, it can check them, and that's what it's doing. Here's another one, right? Where if type of s is object, what do you think we get here? Well, we get string, array, or null. What? Well, because type of null is object in JavaScript. It's one of the mistakes that, that they made, that they then decided, oh, type of null really should be null. Then they tried to fix it. Then that broke a bunch of code. Well, we can't do that. So there it is, tombstone forever, you know, like so. So therefore, you know, but we know that it could still be null in here if you have that kind of a check, right? And down here we know that null's gone. Here's another one. If s double equals undefined, well, s could be null or undefined here, because double equals against null or undefined checks for both of them. But if it's triple equals, now it's only undefined that could pass through here. So all these crazy little rules have been encoded, and the checker will just relentlessly point it out to you. It's like it gets really irritating, but but you know, you want to know this. Okay, so that's nulls. The other, I'd say, cool feature that we did in TypeScript 2.0 is discriminated union types. Let me try to show you those. Here's a classic piece of object-oriented code with an abstract class shape, and then we have a circle and a rectangle and a square, and they either have a radius and width and height or a size, and there's a getArea function that computes the size, and then we make a circle and compute the area. So, OOP 101. Now, a lot of people tell me, yeah, I heard about this TypeScript thing. It sounds really cool, but you know what? I write functional style code and all this OOP stuff. I don't need OOP. You know, it's like TypeScript is all OOP. It's like turning JavaScript into C#. You're right. No, it's not at all. And I want to show you a different way of writing code in the same kind of code in a more functional style. And I want to show you how TypeScript really plays very, very well in that space. So we're going to get rid of the OOP here. Going to get rid of all these classes. And instead, what we're going to put in is a declaration that looks like this, where we say a shape is a thing that can look that can have 3 different layouts. There's a kind property that's the discriminant, and the kind says what kind of shape are you. And you can see here, you can either have circles, rectangles, or squares, and then if you're a circle, you have a radius, and if you're a rectangle, you have a width and a height, et cetera, et cetera. Pretty easy to read, actually. What enables this is a feature called literal types, and this is a type here, circle. This is a type whose only value is the string literal circle. So the only thing you could assign to kind for in here is either circle or rectangle or square. Now, let me also try to show you a function then that computes the area. Now, in an object-oriented solution, I would have had a tight coupling between my code and my data. You know, I have code and data in the same place, right? And that's convenient because it allows me to think of one thing, but it actually brings about some dissonance in a lot of cases. Like one case, for example, is persistence. Let's say I'm writing a drawing program here. I'm going to save my shapes, right? Well, I just want to convert them to JSON, but I can't convert classes to JSON because what about my code? So now I got to have data transfer objects, and I got to take my class instances and put them into JSON and then save that, and then when I read it, I got to take the JSON back and put it into classes, and I have to have these mapping layers and stuff. Lots of stuff, infrastructure, right? That doesn't really add anything to the solution. And the other thing is, what if someone gave me this object hierarchy, but it didn't have a getArea function in it, or method in it? What do I now do? I can't modify this library, so now I got to write a getArea function, but now it's sort of this code smell of instance of checks, and what if I forget one, and blah, 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 and so that doesn't work so well either, right? But in the functional style, code and data are much more separated, and here I basically defined my data, and I have defined the entire domain. I have said shapes can either be one of these three, and that's it. I know in a close-ended manner what everything could be. With OOP, this is another problem, is there might be a fourth kind of shape that I hadn't heard of, that someone derived another one, right? And what do I do in my persistence layer? Who's going to check that I know how to save that one as well, right? And so there are sort of all these interesting problems that come up. So here is what it looks like to do it in the functional style. Now I can just say shape is kind, and then let's say we want to have a circle with a radius. And you'll see that we can actually give you statement completion in here. We know everything. And then getArea, I'm just going to pass a shape like that. Now, one thing now that's really cool is you'll note that my data here is ready to go on the wire. It's just data. I could have JSON.parse this data. I could just save it, store it, So zero friction to save. And in fact, think about what if you were writing a microservice, right, where you get messages in JSON that have a kind and a payload, and then that's what I'm writing here, right? So this is really a very, very common pattern. Now notice what happens here when the type checker gets a hold of all this stuff. Here in here I'm saying switch shape.kind. Let me hover over kind, and you'll see that we know kind could either be a circle or a rectangle or a square at this point, because we've unioned together your possible discriminants, right? Now when I write a switch statement and I say case circle, notice in here that shape has been narrowed down to that case. And so we know exactly that a shape in here is a circle, and therefore we can actually give you statement completion and show you, well, you're a circle and you have a radius and nothing else in here. And so all of these features that you're accustomed to continue to work. What's even more cool is that we sort of know what happens. Let's say I don't have rectangles covered, and then let's look at what is the type of shape here. And you'll see that, well, I handled circles and squares in the switch statement above, so it's been narrowed down to rectangle down here, right? So the type checker actually follows all of your flow and understands what's going on. Now, let me try to look at what happens now. What if I handle all of the cases? Then shape gets narrowed down to a type called never. The checker knows you're never going to get here because you've handled all the cases. Now, we can actually take advantage of that interesting fact, and we could introduce an assert function here called assert never. It's a funny function. It says, here's a function that takes an object whose type should never occur, and it's going to throw an exception saying something went wrong. Now what I can do down here is I can say assert never of shape and get rid of that throw there. Now see what happens here is as long as everything is good, we're going to have a never here, and that's going to pass the check. But what if we forget one? I forgot about rectangles. Checker comes right up and tells me, hey, you didn't handle rectangles. Now that's exhaustiveness checking. If some of you have done functional programming, I mean, this looks an awful lot like ADTs and pattern matching and exhaustiveness checking and all of these patterns that you use in Camel or F# or what have you, but it's all done in JavaScript, and it's all done with no new syntax either. This is a very cool way to program. This is actually how the TypeScript compiler is written internally. We don't have any classes at all in the compiler. The type checker is one big function. It's a very big function. It's like 50-some thousand lines. And all of our syntax trees and whatever, it's all declared in this manner. And it's a cool way to work. And TypeScript really groks it too. So I highly recommend you look at that, and don't think of it just as an OOP exercise. That's another thing you can do. But this truly is a hybrid language that allows you to do both. OK, the other thing I'm going to try and show you now is type checking of JavaScript. Here's an empty directory. I'm going to npm install jQuery, because I'm going to write some jQuery. I'm a retro kind of a dude. And then I'm going to npm install Lodash. There we go. And then I'm going to fire up Visual Studio Code, and I'm going to add a main.js. There we go. And now I'm good to go. And I'm going to type $, and boom, statement completion. Where did that come from? I'm in JavaScript here. How do you know anything about $? Well, we know what NPM modules you have installed. We can go consult node underbar modules, and then we can go to NPM and see if there are type definitions available for those modules. And if there are, we can suck them down and auto-provision your IDE with the types that correspond to the modules that you're using, even though you haven't said anything about TypeScript. You're just programming in JavaScript. All of a sudden, we can give you this great experience based on all of that type information. For example, we also know about Lodash. Yes, there's type information available for Lodash. So now I can say underbar.filter, pass an array of numbers, like that. And now we can start flowing the type. So in the callback here, we know that X is going to be a number. And so we know what methods are available on number. And so without you doing anything, you actually get a lot of the benefits. And this is what's cool about TypeScript being a superset of JavaScript, is that JavaScript is just TypeScript with no type annotations. But that doesn't mean the checker can't check. It can check a lot. And in fact, as we thought about this, we sort of realized that, hey, what if we had a type checking mode that was more of a conservative checking mode? You know, when we're checking TypeScript, we're basically, if we're unsure about something, we're going to whine and give you an error and make you fix it just so we can be absolutely certain that we've checked everything. But what if we had a mode that was sort of the opposite, where, well, if it could be true, great. But if we for sure know this is wrong, why don't we let you know about it? And the checker can do that, and it can actually do a really great job of it, particularly on modern JavaScript that's written with modules and classes, because we can statically analyze the structure of that. So let me show you what that looks like in real life. Let me fire up. On a project here called GitHub Crawler, which is an open source project that we just grabbed from GitHub. It's used internally by Microsoft Open, so it doesn't really matter what it is. It's just a bunch of JavaScript. And I'm just going to open all of the files here. There we go. And lo and behold, what I've done here, the only thing I did after getting cloning this repo is I added a config file where I turn on check.js. And that basically tells the compiler, hey, give it a shot. Check that JavaScript and see what you can find out. And we actually find out a lot of stuff. Now this, I should also say, this is a snap in time of a particular repo where the programmers later fixed the bugs. we actually grabbed a copy about a month later for another demo, and whoa, what happened? The bugs are gone. Oh, well, they found the bugs themselves the hard way, right? But so we had to go back to that previous commit where the bugs were there. So that's what you're seeing here. Here we go. First one is in here. We're calling a method, and it's saying the parameters don't match. Well, let's say go to definition. Notice that statement completion works, and whoa, this thing takes no parameters, and they're passing it an argument. That doesn't make sense. We should tell you something about that, right? So we do. So let's not pass an argument there. Here's another one. Same thing. We're passing 2 arguments. Function takes 1 argument. God knows what's going to happen to the other, but let's make it take another argument. And there, that goes away. here's something else that's sort of suspect. We're newing up an arrow object, and then we're starting to jam properties onto it. But arrow objects don't have underbar types and URL. But of course, you might mean to do this. So you'll note that we have a little light bulb there. And if I pop up the suggestion, it says, oh, just ignore this error message. And notice how we put a little comment on the line above that says, ignore errors on the next line. And so you can sort of go through and just tell it, yeah, okay, that's fine. I've looked at that one. I don't mind that one. We're good. We're good. There. And they go away. Here's another one. New request.payload, except if we go to request, there is no payload in here, but we could add a payload. It's actually good practice to always initialize your properties in the constructor because the VM will do better layout that way, and then that error goes away. Same thing here. There simply isn't an events method on, so I don't know how this code could have ever run. Well, oh, it's code in a callback. I guess that callback never got called, right? So, so I guess they don't have test coverage of this particular one, so we'll just get rid of that. Here's another one. It says there's no type property on request. Well, one of the suggestions that we have here, if I control dot, is just go initialize one. So we'll just simply have it add, and now if I say go to definition, you'll see this line of code that our code fix inserted. So you can actually just ask for the fix, if you will. Here's another one that's similar to that. I'm just going to say, yep, go initialize this in the constructor. If we go to the constructor, you see that we added another one. I can keep going. There's maybe one that I think is interesting here. Moment.diff, and it says there's no diff. Then I went and looked at the type declaration and said, no, there is a diff. But it's on the result of calling moment, not on, you know. So that one took me a little while to think through. But this is the kind of stuff that type checkers can find because for moment, we actually could find the type declaration files for that by auto-provisioning and then checking against that. And for all of the other stuff you saw in the classes, it's because we can analyze the static layout. So there's a whole bunch of cool stuff we can do, even without you doing anything to your code. But then, of course, since TypeScript is a superset, you can ease into it and start writing type annotations, and then we can do even better. But we're really very focused on reducing that glide slope into TypeScript and allowing you to stop and actually just still have JavaScript. All right, let me go back and quickly hop through the last few slides. Type system, I mean, my point really is at the bottom. You can look at the slides afterwards, but this type system is both object-oriented and functional, and generic, and gradual, and structural, and it's a very interesting type system. It does a lot of stuff that I haven't seen any type systems do before. It's a lot of fun to work on. Tooling, you saw me use Visual Studio Code. Of course, you can use Big Visual Studio, but you can also use a variety of IDEs out there. We actually have great support for all of these IDEs, and the reason we do is that we've engineered TypeScript to be this service that you can use from your editor plugin. So you don't have to understand anything. You just have to tell us about all the edits that happen, and then we can cough up all of the answers from this out-of-process node server that we run that talks to your extension. TypeScript adoption, we are growing leaps and bounds. We're up to more than 4 million downloads per month now on NPM. We recently made it into the top 20 programming languages in RedMonk's survey. We're up there now as number 17 with Scala and Swift. So it's great to see that the community is really picking up on TypeScript at this point. One that particularly made me happy is that we are now in the top 3 most loved programming languages on Stack Overflow. Right behind, thank you. Behind Smalltalk and Rust. One morning, the other day, I was reading my coffee, and whoa, look at this article here. Someone at the engineering group at Slack was writing about how they spent 6 months rewriting all of their JavaScript apps to TypeScript, and they love it. And so you know, and lots of other companies are doing it. And in fact, a lot of the JavaScript frameworks are using TypeScript. And honestly, this is perhaps the most important slide, because if anyone knows JavaScript and all of the issues and the JavaScript community, it's the people writing the frameworks. And look at how many of them are using TypeScript in their day-to-day development, and that really warms my heart. That's it pretty much for me here. I encourage you to go visit typescriptlang.org, which just got a revamp. We have a whole bunch of new getting started guides that are really cool, that allows you to see how you get started with Angular, React, or Vue, or what have you. Come talk to us on the issue tracker on GitHub. The whole team is there every day. It's where we live. And we also have a booth downstairs. Come talk to us. I'm going to pop down there as much as I can. But we have Daniel and Bowden down there, great guys to talk to about TypeScript. So that's it for me. Thanks for coming, and thanks for using our product. Thank you.